Okay, so now that we've talked about the shapes of molecules, we can talk about the polarity of the molecules. And polarity is going to refer to the electrical charge of a bond or molecule. Polar bonds are going to form when two atoms that are sharing electrons have different electronegativity values. So when they are pulled from opposite sides of the periodic table, they're ionic. There's a very large electronegativity difference there. But even within the nonmetals, when you have a covalent bond, there can still be a big enough difference between those electronegativity values to form a polar bond. In the bonding, our shared pairs of electrons would be pulled between the nuclei of the two atoms. So it's like a tug of war almost. So these pulling are called intermolecular forces. And they are weak attractive forces that are going to hold a molecular substance together. Without these forces, all of our molecular compounds would be in the gaseous state. And so there are two types of molecular forces, and one of these types has two subtypes. So 3 types total, but 2 of them fall under one category. First category are hydrogen bonds, and just like they sound, it's going to be when the hydrogen of one atom is attracted to a highly electronegative atom of another molecule. So these are not chemical bonds. Chemical bonds are about 10 times stronger than hydrogen bonding, but they are strong enough to affect some physical properties. So they're going to change the melting and boiling points, increasing it, and they'll also increase the vapor pressure of a molecule. And that's just the gas that forms just above the surface of a liquid. Next are the van der Waals, and this is the one that breaks down into 2 subcategories. The first one being dispersion forces. Dispersion forces are the weakest of all of the forces, so they're not very difficult to break. And they are caused by the motion of electrons. So you can kind of think static electricity. So the more electrons you have, the stronger this dispersion force is going to be, but it's still pretty easy to break those bonds. So strength is going to increase as the number of your electrons increases. The second van der Waals is called a dipole interaction. We know di means 2 poles, so there's 2 opposite poles. So very similar to an ionic bond, behaves the same way as a hydrogen bond. It's going to be between 2 polar molecules. So the least electronegative atom in the molecule is going to be attracted to a highly electronegative atom in another molecule. So it's going to bring these guys together. Again, similar to hydrogen bonding, except they're not going to have hydrogen. They are similar to, but much weaker than ionic bonding.